or expressing the concentration of a solution. See, solution is being made by mixing solute and solvent. So when you say methods for expressing the concentration of solution means we mean that how much amount of solute is present in a certain amount of solvent. Okay. Now, so now in this case, when you make the solution, it is not necessarily that you should know the molecular mass of a substance. So we can make the solution in two ways, with knowing molecular mass of a substance and without knowing molecular mass of a substance. Okay? Most of the solution that you have made in your life till now, in most of the cases, you do not know the molecular mass of the solution. You have made 100 times of solution of sugar in water, but I don't know whether you know what is the molecular mass of sugar. Okay? I doubt whether immediately you can tell me what is the molecular mass of sodium chloride. But what did you do? We have taken certain amount of salt and we have added it in a glass. But you did not measure also how much amount of water that you have taken and how much amount of salt that you have taken or sugar you have taken. But generally we cannot do like this. Okay. So it can be classified in two categories. One, so now we will go for percentage composition. Okay. So percentage composition is like this, that percentage composition is there. Percentage composition can be done in three ways. One, we take both the solute and the solvent by mass or weight. And as it is percentage, it should be always brought to the level of 100. Or we can take both solute and solvent in forms of liquid. Third, which is very, very common, we take the solute by weight and solvent by volume. No. Okay. Now one. So we call it mass percentage. Or in plain language, we can call it weight by weight. In abbreviation form, what do you write? W by W. So what is this? We write now here. Mass percentage of this W by W is equal to what? Mass of the solute in grams. Divided by total mass of the solution. So how can you define it? It is defined as the mass of solute in gram dissolved per per 100 gram of the per 100 gram of the solution. That is, suppose you have taken a beaker. Okay. This is the say this is the weighing machine. Okay, this is the weighing machine you have. Okay, and two it is added solvent. And you have added solute. Total weight of the solution will be 100 grams. Total weight of the solution should be 100 grams. Now see here, 100 gram is what? 100 gram is the total of the solution is equal to what? Is equal to the sum of weight of solute plus weight of solvent. Don't forget. For volume percent, or what we can say call it volume by volume percentage. It is V by V percent. So what will be this? Volume of the solution divided by total, sorry, in milliliter. Total volume of the solution into 100. So it is defined as the volume of solute in ml dissolved per 100 ml of the solution. Okay. So now I will not draw it like this, because for that, suppose I have taken here a solution and you just, because say it is graduated, it is 100. Then say it is 50. So now total volume of the solution should be this. Okay. Right now here, volume percentage, and this is V by V percent. So what you have here now? Here you have solvent and so. So in this case, what will happen now here? 100 ml will be equal to volume of solute plus volume of the solvent. This is called mass by volume. Generally, you follow this one, mass by volume percent. Okay, that is what we call it, W by G percent. Okay, so it is equal to, okay, it is defined as the mass of solute in grams dissolved in 100 ml. See, one is weight and there is volume. Okay, dissolved in 100 ml of the solution. Okay, so what we can write now here? Mass by volume percent or equal to what? W by V. Okay, so it is equal to mass of solute in grams volume of solution in ml into 100. Familiar? Say you are making a cup of red tea. So you have taken the red liquor. You may measure it or you may not measure it. Then to that you add sugar. Sugar comes in weight. You add it by spoon. And total volume of the solution you know. Because if you take more, then it will spill. It will overflow. So this is the solution we are mostly you are using in our house as well as in the laboratory. Okay. Now suppose if the substance which is we have used as a solute is very small, very minute. In that case, we do not use this scale. So it is a matter of contamination in water, or it is a matter of air pollution. So in that case, the volume of air or mass of air is so large, but the harmful substance is very, very less. So in that case, we use a separate term for such dilute solutions. We call them as ppm, parts per million. Okay. Parts per, we call it ppm. When the solute is present in trace quantities, it is convenient to express the concentration in parts per. Okay, so it is defined as the quantity of solute in grams. Present in 10 to the power 6 grams of solute. Mind you, we are not using solvent, always solution. Now, this unit is expressed what? This unit is generally expressed, used to indicate pollution. Both in air or water and hardness of ppm equal to amount of solute total mass of solution into 10⁶. Every time you did not write concentration in grams in class 11, you have already studied about mole fraction. Is it not? So you can express them in form of moles also. Okay. So you can write here now mole. Remember mole fraction that you have studied in class 11? Huh? Or all finished? Digested, na? Good. It is defined as the ratio of number of moles of any one component. It can be solute or it can be solvent also. Any one component of the solution to the total number of moles of all the components of the. Okay, see here. Don't write this definition. First try to understand. Let a solution is being made by dissolving an A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. Then moles and NB moles of solutes A and B in NC moles of solvents. Okay, solvent C. Acha, now wait. It is denoted by here. It is not X, it is chi. CHI. Okay, so let me write here mole fraction of A. See, A. How many moles are there? N. N. Then A is subscript. By what does it say? By the total number of moles of all the components of the solution. See, solution is made of, solvent is A, and we have resolved A, sorry, made of solvent is C, and we have added solute A and B. So, total number of moles is what? Na, Nb. Oh, sorry. Very sorry. What will write now here? Chi. Chi A is equal to Na plus Nb. Mole fraction of B. Chi B. B. Then mole fraction of chi C equal to Nc Na Nb. Right now. Okay, now what I'll do? I'll add chi A, chi B, chi C. Oh, I'll add top, because if I write sitting now, I have to develop pain. Start edit. Okay. So right now here, chi A. See, X with the tail, huh? This is also right. Is equal to what? N A N B. Sorry, I have written already that. N plus N B N A N B N. That for this N A N B. LCM is same only. What will write here? Equal to Na Nb Nc Na Nb. Okay. So we'll not cross like this. You know, simple rule of mathematics. You want to cancel it. You have to put a bracket. So what is the moral of the story? It says sum of the mole fraction of all the components present in a solution is equal to unity. Unity means what? This will always require in future for your mathematical derivation. So now we'll go for B. See, from here you require the for mole fraction otherwise you must know the molar mass because you know what is mole is the amount of substance taken divided by is molar mass. So what we will write now here? Molar solution or molar. You know the symbol. So what is the definition of this one? It is the number of moles present per liter of the okay. Now see here. Let us assume A is the solvent and B is the solute. Okay. So therefore, M is equal to what? What does it say? Number of moles of ice. Solute. Number of moles of solute present per liter of the solute. So this is the number of moles of solute. Let me write here N. V is the volume of solute. Okay. In liter. So I'll write now here V. M equal to NB by V. All right. Now, every time I need not make 1 liter of solution. Suppose I require only 50 ml of the solution. Then, as if I go for the definition, then I have to take this much mole of the solute and I have to dissolve in 1 liter of the solution. From there, I will use 50 ml, then 950 ml of the solution I have to throw. So it is the wastage of the solute as well as solvent chemicals are very costly. So in that case, we will try to convert it into milliliter. So what you can do? Conversion by if you go for conversion, it comes to NV V by 1000 ml. So this 1000 will go to the top. Now you are pretty mature, so I will not write it. I'll write here 1000 and here I write in ml. Okay, now what is NB is what? Moles of solute. Now, how to calculate the moles of solute? So I'll write here now. NB is equal to mass of solute. What is solute? A in grams. Divided by what? Molar mass. Means molecular weight. Molar mass. Molar mass means molecular weight. Molar mass of in gram mole inverse. So it comes what? Suppose if I consider this one to be WA, sorry, WB, too much. WB by MB. MB is the molar mass of solute, WB is the weight of solute. Right? So I can substitute this one here. So NB is this. So I'll write now here. Therefore, is equal to what? WB by MB into 1000 divided by what? Divided by V in. So what will come now here? This will come down. Therefore, M is equal to WB 1000 divided by MB V in. If you follow this, even you can make a solution of 10 ml also. I'll do little extra for your entrance exam or for any other numerical. Acha, before that, I have to do one numerical. No, this numerical you have done in class. We have done what is that is? What is the number? D, I think. No? So D1. We write now here. This one you have written now. You write here molarity D1. Now we'll do 2. Written relation between molarity and mass by volume. Percentage. Say it is X%. Okay. So now we know M is equal to what? M is equal to WB 1000 and MB into V in mass by volume. So it is X%. Solution. X% means what? X gram is there. What is this? WB is equal to X. And how much amount of solution is there? V, 100 ml. So V is equal to 100. So if I put it there, so therefore M will be equal to what? X, W is what? X into 1000 MB, V is equal to what? 100. So what is come? So therefore M is equal to 10x by MB. Please remember, this is a very wonderful relationship. Long sum directly put, you will be given molecular mass. So you put X is the amount of the substance. Huh? Okay, then we'll do one sum. Calculate the molarity of %5 mass by volume. Okay. See here. Molar mass of HQ support is 98 gram mole inverse. All right. Now what is M now? See here. M is equal to 10x by M. So what is that? 5 gram. 5 gram. And what is this? MB 98 gram mole inverse. So M is equal to 10 into 5 divided by 98. Gram and gram will get cancelled. So what will happen? Huh? Mole is below now, it will come here. Mole. Find it. Divide.
Five.
0.5 something will be there. How much? It will not be 0.5 there, it will be less than 5. Do nicely.
Sir, I got 0.51.
0.5. Hey, 50 divided by 98. Is it 50 divided by 100 or what? 0.5. Yes. Okay. This is the one. এতটুকু বুদ্ধি নাই নাকি? 50 divided by 100 will be 0.5. 50 to 98 is too less than 100, na? Okay, forget. Okay. Third. relation between molarity and mass by mass. Percentage solution. See, you are very interesting. Mass by volume, V was equal to 100. But here, the volume of the solution is not given. Mass of the solution is being given. So I have to convert because M is equal to what? M is equal to WB 1000 MB and V. But here the volume is not given. Because mass of the solution may be more than 100 ml or maybe less than 100 ml. Okay? So, what to do? See, let D be the density of the solution. Mass of the solution is 100 gram. Therefore, volume of the solution. See, we know density is equal to what? Mass by volume. Mass by volume. So volume will be equal to what? W by D. What is the solution? 100 gram. Huh? So what should I write now here? Volume of the solution is equal to what? 100 gram divided by D. Huh? So it is grams by what? ML, na? So what should I write? So I'll write now here. Now what is WB? See here. X. X. So M is equal to what? WB into 100 divided by MB, sorry, 1000. 100 by D, or M is equal to, sorry, 10 into X, 10 into X into 1000. Hey, what did I write? First one I got 10. Sorry. sorry. So it is D into X into 1000. This has gone up, na? So MB into 100. So therefore M equal to what? M equal to 10 dx by so now we will do a numerical. calculate the molarity of 15% H2SO4 by mass. Density of the solution is 1.2 gram. So right now here, M is equal to x 10 x d by m. So I'll not tell you. You know everything now. Molar mass of sulfuric acid, you know it by this time. X also you know, D also you know. Find out. And X is 15, 1.2 divided by 98 is 1.8. Good. So I'll go little bit more. Huh? It will be you will be requiring in your practical. Huh? So it is 4. It's called dilution. If D1 ml of M1 molar solution is diluted to V2 ml of V2 ml, having M2 molarity. If you dilute it, the molarity changes. Okay. Then M1 E1 is equal to M2. Calculate the molarity of sodium hydroxide solution if 25 ml of 5 molar solution is diluted to 250 ml. Calculate. See, this one you know. If this is if this is 25 ml is M1 and M1 is 5 molar, Total whole the solution is new volume is what? 250 ml. Why not M2?
More.
How come you get like this? See here. M1 is C. M1 is 5. V1 is 25 ml. V2 250 ml. M2 you are supposed to find. Okay. I'll write like this. M2 V2 is equal to M1 V1. Anything which want to calculate, we keep it in the left hand side or not. So M2 is M1 V1 by V2. And 5 into 25. Total is 250. So how much it comes? Pagal hai na kya? Is it not this? How do you get 50? If you dilute, the molarity strength will decrease, na? If N1 moles of M1 V1 solution react with N2 moles of M2 V2 solution, then we'll find M1 V1 by N1 will be equal to M2 V2 by N. If M1 V1 and M2 V2 of solution of same substance is mixed together, then the molarity of the resultant solution M will be m is equal to m1 v1 m2 v2 divided by v1. So you please don't get nervous. This is a solution whose molar it is m1 and the volume is v1. Okay, so this is the one. So it is hydrochloric acid or sodium hydroxide. Then I have taken another solution and m2v2. Okay, now both the solution I have mixed in a big container. Okay, so what is the volume now here? Volume is v1 plus. Now what is the molarity of the resultant volume? Molarity m is equal to what? Then you understand the theory. Right now here 150 ml of 4 molar solution of sodium hydroxide is mixed with 100 ml of 3 molar sodium hydroxide solution. Calculate the strength means molarity, strength of the resultant mixture. So what will write now here? M1 is 4. V1 is how much? 150 ml. M2 is what? 3 mol. And V2 is equal to what? Find out now.
Yes,
So
sir.
it will be
I got 3 point.
equal to 4 into 150, 3 into 100, 150 plus 100. So how much it comes? 4 into 150 is how much?
600.
Okay. So it comes to 900 by 250. So how much it comes?
3.6.
3.6.
3.6.
Okay. Your textbook is useless. I think I can write better than that textbook. Okay. Now we'll go for Molal solution. Or molarity. What is the symbol? Mol. So what is this? It is the number of moles of solute present in 1 kg sieve. Try to see. Sorry. Per kg of not solution, solvent. Solvent. Okay. So what is molarity now? In that case, M is equal to, for solute we write B into, let me write here, WA in T. What is WA? Weight of solvent in kg. I'll convert it to gram. You divide it with 1000. 1000 will go to the top. Will be equal to what? And 1000 WA in gram. Now you know NV is what? NV is WA by M. So therefore, this is equal to WB by MB into 1000 by W. Therefore, MB is equal to WB 1000 divided by MB. You have done this work in class 11. So I'll tell you to do it at home. So with this, I finish it.
Thank you, sir.
Bye, sir.
Okay,
Thank you, sir.
I can't tell
Thank
you.
you, sir.
Thank you, sir.
Now to
Thank you, sir.
every only.
Bye, sir.
Bye bye.